Hi guys, in this series of videos, I'm going to do something different. I'm going to go through Angela Yu's 100 Days of Code Python Bootcamp video series, but in Common Lisp. So the idea is to introduce Common Lisp concepts one at a time through the same set of projects like in the original. So we're not going to organize this series by concept but by project and look at various concepts as they come up. So this means the difficulty curve is going to be all over the place. There are going to be some videos which are going to be very easy, and there are some where we might introduce a lot of different concepts. So the idea here is to try a different approach to playing around with Common Lisp. So let's see how it goes. By the way, when I say the Python bootcamp, the one I refer to is this one on Udemy, because there are quite a few variants with the same name, 100 Days of Code. There is this one, there is this one. There are different instructors, but I'm going to use this one and follow the projects over here. Let's see how it goes. Let's start with day one. So the problem here is actually quite simple, especially in Python. It's called a band name generator, but what it's doing is it's just going to prompt for a city name and you can enter it, and it's going to prompt for an animal name and you can enter it, and finally it just spits out your band name is the city plus the animal, right? So this is quite simple in Python, but if it's your first time going to coming to Common Lisp, this is going to be a lot more complicated. So I have kind of tried out 4 or 5 different versions of this simple program just to give a good broad spectrum of options. So we're going to learn a few different concepts here. This is significantly more difficult and convoluted compared to the Python version, but that is what it is. Firstly, this is an Emacs and this is an org mode file, which means I'm going to be using org babel to evaluate my Lisp chunks. And of course, with Slime, the thing is with Common Lisp, Emacs is not optional. Emacs is probably the only way to do this right. So I strongly recommend taking a workflow like this. And you'll see as I go through these programs, the kind of convenience, the kind of end-to-end live control we have over the program. You'll notice the first thing I've done here, I am not doing things at the top level like you would normally do when you get started with a language, but instead I'm going to do these things inside a function. There is a reason for this because you have the def var and setq forms in Common Lisp, but they are not what you use inside a function. In Python, when you do variable creation or assignment, the syntax at the top level is the same as what you do inside a function. So it makes sense to go in that direction. Here, we do something different. So this is the function. You might be able to easily understand that defun means we are actually defining a function, and then the name of the function, and then the arguments of the function. In this case, this is empty. So we are not taking in anything. Now, before we go in, you have to understand 2 important keywords here, basically progn and let. So these are special forms in Common Lisp. So we'll look at each of this at a time. So in the Common Lisp REPL, I can try various things. For example, a simple form like this is a simple expression. Now, if I want to run multiple expressions, if I want to actually run 2 things, one after the other, the way we do this is using the progn special form. So essentially, this is like a program with forms one after the other. So if I do something like this, what is happening here is it's going to take a list. Everything in Lisp is a list, obviously, of expressions, evaluate them one after the other, and return the value of the last one. So in this case, This expression is actually evaluated, but we are not done anything with it, so you don't see it. Only this is actually used. Now, if I use the simple print option, so if I just say something like this kind of works. Again, since Common Lisp is a complicated language, there are a lot of ways to do the same thing. Print, as you can see here, actually introduces extra new line. So if I use this variant of print, using something different going on here, there is no new line, but there is also no double quotes around the string. There is one more variant, print 1, which would be somewhere in the middle of these two options. You don't get the new line, but you also get the double quotes. So Common Lisp has a lot of features. So this is a very simple example, a simple hello world, and you can see that there are at least 3 different variants of the same default print function. Now, you see 2 entries here. One is the actual print and the other is the return value of the expression. So I can now, just to demonstrate how Progon works, have multiple print statements here. So let's say line 1 and then line 2. So now you see that we have both of these expressions actually executing one after the other. So that is where we use Progon. Progon is one of the 2 important elements I wanted to show you here. The other is let. Let is a way to create bindings for the rest of your expressions. Let is actually the primary way by which we create variables to use in the body of functions or other blocks of statements. So for example, if I want to add 2 variables, a and b, with values 1 and 2, the actual Common Lisp recommended way to organize this is something like this. So you start with the let special form, and basically you have a list of lists, right? There are going to be a lot of lists here, so you have to be careful about how the syntax looks. But this is a list, inner list. So where we are saying I want to set a to 1, and then I want to set b to 2, right? So this is the second declaration, and finally we close off the primary argument to let. When you have done this, we can now have a body of statements, expressions here, which will be executed one after the other. So this is a bit like Progon, right? So let as an implicit Progon. So I can have multiple things here. For example, I can print, so I can just, let's say, print A, print B, and let's just say add A and B. So what will happen is these statements, these lines are going to be executed one after the other, and finally this last expression's return value is actually returned. The overall return value of the let expression is the return of the last. And on these lines here, the body of the let expression, you have these variables available for you. So this 1 and 2 is this printed values of this. Because you use print C, there is no space or there's no new line. Finally, you get the return value of A plus B. With this core logic of Progon and let, so maybe now you can kind of follow along to see what's going on here. We start with the let because we want to create 2 variables, A1 and A2, which are going to actually hold our inputs from the user, the city and animal. Now, to get the value of A1, we actually want to execute 2 statements, 2 expressions. And the way we are doing that is wrapping that with the Progon. So we have a Progon, and then we print with city, which is going to be the input to the user. And then we use readline to get back the response from the user. So we do this exact thing again, another sub expression here, where we are setting the value of A2 with a similar Progon, just prompting the user to get their animal name and then get it in. And then finally, this line, the body of the let, is going to use that two inputs. In our case, we just want to concatenate these. So the way we have done here is using the concatenate function, which is just going to take your inputs. But before that, it requires the types of the inputs, because the same concatenate can be used with other types like lists. So this concatenate, we're asking it to concatenate strings and then providing the strings that we want to concatenate. Here A1 and A2 are the variables, and they will now have the value that we have got from the user. Let's evaluate this using awk Babel. I have a single keystroke to execute this in our REPL. So if I go back here, this context has that down. Now here we will call the function that we have defined, and it asks for our input as we expect. This is in the let expression right now, and we get the final output. It's printed, but it's also returned because that's the last statement in let. We can leave this right here, right? We do have a function that works, everything is fine. But I'm going to introduce a few variants of this function just to introduce more concepts, right? So the first thing we'll do is we look at a variant which looks pretty much exactly the same. We have the same let structure with two bindings, but instead of using the concatenate function, we'll use the format function. Now, the format is equivalent to the printf that you have in C or the f string that you have in Python, but it is quite different compared to those, because it's actually older than C. So this tilde that you see here is the equivalent of the percent that you see in C. So let's look at this function again. So it's very simple. We have format, which is just going to format a string. We have the first argument, which is going to be nil for now. I'll come back to what that means. But for now, it will not print anything, but just return a value, the formatted string. Then you have your actual format string that you want to have with different kinds of format specifiers. Tilde A will have a simple representation of whatever you pass in after that. And then we pass in A1 and A2. I can execute this and show you that it works. And you see the exact same thing that we saw last time. This is because this is what we are doing. Format nil for the moment, the string format string followed by arguments, and you see it working. So this is a simple variant. Instead of using concatenate, we can use format. Now we can go one step further, which I will do in the following functions, where instead of format nil, we will do something different. We will use format t. And if you see this in comparison to the previous one, what we're doing is it is actually printing out the string, formatted string, directly to stdout and not returning anything. That's the difference between these two variants. This argument here is the stream where we want to send the formatted string to. By default, if you use nil, it will kind of not go anywhere, but just you be used as a return value. If you use t, it will go to the default stdout. You can actually send it elsewhere, like to a file, by using this argument. Now that we have the simple version, let's go to the next version. If you see our current version, you see we have switched out format, that's all fine, but we are kind of doing this repetition of task twice. We're doing the exact same thing for both the variables. So one might be tempted to, refactor that into a function, right? Makes sense. Now, The simplest way you could do this is just have a separate defun, right? Like instead of having ban name gen, you can create one more function to do as a helper function with this, and you could use it, right? And that's fine. But you actually only need this helper function within the context of this function. And so the cleanest thing to do here would be to actually create a function here and use it here. And let's do exactly that. To do that though, we will have to introduce 2 or 3 new concepts. Specifically in this variant, as you can see here, we are going to introduce the concept of lambda, which is foundational to all of functional programming, and it's pretty important in Lisp as well. We're going to look at let star, which is a bit like let but slightly different, and we'll see why that is. And we'll also look at the func call function. Let's start with lambda. If you have any experience of functional programming, even if it's in Python, lambda is going to be pretty obvious. If we just use the lambda form, the point of a lambda is an anonymous function. It doesn't have a name, so you don't have to give it a name like the way you do it in defun. Instead, you just directly go to the arguments, right? So I can create, let's say it assumes I take an argument and I do something like this. Now, if I run this, you will see that it has actually created the lambda function, and it's just there because we didn't assign it, we can't use it, it is just there. Now, because we used let last time, one might think to just put a lambda, as you can see how I've done here, into a let body, right? And that's great. I mean, that would work. That would exactly work. But let has a slight problem, which we'll look at right now. Let defines variables that you specify in parallel. What I mean by that is, if you have a let line with A and then B, those two variables are defined without knowledge of each other. For example, if I do something like this, what I want to do is here set A to 1 on this line and then set B to just A plus 1, right? And then I just want to return the value of B. But this actually doesn't work. As you can see here, it complains that the variable A is unbound. So I'm going to abort this because we don't care about this. But the reason for this is, like I mentioned earlier, these two lines are actually defined in parallel. So B is when this line is executed, B is this expression, sorry, is not aware of this expression. So the solution to this is very simple. It's exactly what we do before, but we use a let star. And a let star is actually going to ensure that these expressions are executed in this order and there is a visibility between these expressions. So this is the same that I've done last time, but this time it is actually going to give us the answer 2, because when this line is being executed, A is visible and A's value is 1, so it's used and finally returned here in part of P. So we have looked at lambda, that is clear. We have looked at let star, and the reason we need a let star here is so that this lambda, which is saved as the variable f, is actually available on the other lines, on the lines where we get execute and get the values of a1 and a2. Even without let star, even with let, f would have actually been visible in the body of the let expression. So on this line, f was always going to be visible, even in the case of let, but on these lines, f would not be visible if you used just let instead of let star. Now we have 2 out of the 3 concepts, and the third concept is very simple. To run the lambda, you have to use the func call function. You cannot just call the function using f. So if I go back and go back to the lambda we defined, we have the lambda, right? And we want to use the lambda. So the simplest way to use this lambda is to actually pass it a variable, right? So you're basically defining the lambda inline and then using the lambda immediately, and this will work. So what you've done is the lambda is here, and the argument 10 is going to be passed to this lambda in the place of a, and then this expression a plus 1 would execute with this value 10. But if I were to save this lambda, so if I simply go back to this definition, and this time I'm going to make this into a global variable. So this is creating a new global variable with this lambda. It's created, it's available as L, but I want to use this L and I do this, we run into this exact problem. L is undefined. That's not true, we just saw it. L is defined, but L is a function. So the way to use this is very simple. Do this and it works. So I hope this use of func call is clear. We have the function, the lambda stored in a variable. You want to use the variable, you call func call. So there is a statement here to be made about Lisp called basically type 1 and type 2, but I'm not going to go into that the moment, but you can look into that if you're interested. So this version, we have successfully refactored the main execution piece into a separate lambda, use the let star so that we can use that lambda twice, and use func call to actually call the lambda. You might notice here that we don't have a program. The lambda's body, right, is these two expressions which we had the same as before, but we don't need a program because in lambda and in defin, for instance, the program is implicit. The expressions that follow the body are actually treated as one sequence to be executed. So I hope this clarifies this third variant of the same function. The next version we are going to see is a minor variant of this one. So specifically, since we have this func call and that's a bit clunky, there is a way to actually remove this. To do that, we're going to use, in this version, the flet form. So you've already seen two variants of let, the let and the let star. Now this is the third variant called flet, and it may be obvious you are actually creating a function with the flet form. So f is the name of the function. We don't have to use the lambda form anymore. We use directly the name of the function we want to create, the argument list, and then the body, right? And if you see here, this flet is basically an outer level let, and then there is another let inside for the variables. So this is because you can't mix variables and function creation in a single let. You have to use two different lets, one flet version and one let version, and everything else is the same. Except now, in the body of the flet, we can use the function f directly without having to use func. We have already seen a few different variants today, and we can actually end this video right here. But I'm going to go one step ahead and talk about macros. So Common Lisp has a few very cool things, and macros are one of those core language features which make that possible. So it's only fitting that we talk about macros in the very first video. This can be a bit complex, so don't worry if you don't get all of it. We'll come back to this again and again and again. So if you look at this function here, it's very similar to before, what you have seen. There is a small difference. We're going to use a different version of let. Instead of flet, we're using macro. So what that means is, instead of defining f as a function like we did before, we are going to define f as a macro. And then if you see, we use f as we did before as a function. If you're aware of C macros, this particular example can be kind of compared to that, wherein we want to actually replace this expression here with the expanded form of these expressions. And if you see these lines, it's actually the simple prog version that we used before in a repeating manner. So earlier we used two prog sections, then we replace that with a function, and here we are kind of going back to using two prog expressions, except that we are going to use a macro to automatically convert this expression here to look like the prog form. So let's look at these three expressions. So we have the first expression is just a list of items 1, 2, and 3. So that's normal. That's what we do in every language. The second expression is actually code, where we are adding 1 and 2, right? So this is understandable. The third expression is actually the same second expression, the code, but because it's quoted, it becomes data. So that is the point of Lisp's S expression format, the use of parentheses and lists. You can easily go from code to data and also back from data to code. So what I mean by that is, if you take this data line and try to evaluate it, you actually get the result. This is because this data is being converted back into code. So the point of macros is to actually write some code which is quoted, that is, it becomes data, and then is used to replace the code at compile time. So let's take a different example, right? So let's start with something like this. So this would just spit out the values a and b. So it's returning out a list plus a and b. Now, if we add a function, let's say we wanted to create a function to do inline operations. So what we want to do is support something like this, right? Where you give two numbers and then you have the math operation in the middle, like what you have in other languages. So if I do something like this, to actually get this working, you would have to do something like this. And then when calling it, you will have to pass the quoted value of the plus and not the symbol itself. So this kind of works. We have seen func call before, and you have seen how instead of actually using plus, we are quoting plus so that we can send in it as a symbol. But that's not what we want. We would like to actually call something like this, right? This is more natural if that's what we want to do, but this doesn't work, right? So that's because when a function is running, all of its arguments are evaluated. So the 10, the plus, and 20 are all evaluated. But we don't want the plus to be evaluated right now. What we want to do is we want to convert this argument list into a different list, which is plus 10, 20, and hopefully that works. So the def macro special form is used to do exactly this. So if I create a new def macro for inline 1, exactly like what we've been trying right now, and pass the same three things as we thought, and now do this, right? So will this work? So what are we doing? We are just trying to quote and replace that initial input code with a different input code, right? Let's try using this, and there are some warnings, and you will see in a moment why that's the case. So now we can actually pass in plus directly, because it's not, when a macro is expanded, it's not actually going to call the function. But you see, this kind of doesn't work, because it says the variable a is unbound. There is no a variable here. Let's just abort this run and go back. And the way to understand this is by using the macro expand on the thing that we tried to do earlier, which is in line 1, 10, 10 plus 20, right? And you'll see exactly what's going on, what's going wrong here, right? So, like eval, macro expand is a way to actually take a quoted code, so data, and then actually expand by running the macros in it. And you see here that this inline 1, 10 plus 20 is getting expanded as op a b, which is not what we wanted. So if we go back to our macro definition, we'll see the problem immediately. Once you start the quote, what follows after that is literal string. It's not used as a variable, it's just literally used as the symbol that it stands for. So this is where the backquote form comes in. So by starting a backtick and then by using comma in front of the variables that you want to quote, want to unquote, what happens is you're asking at compile time to convert a of b and replace op with the value that actually comes in at compile time. And because you have used backquote, it will go back into being that list. So if I just redefine this inline 1 macro and try to expand the thing that we were trying earlier, you will see that it looks correct. That's what we want. Now what actually happens is if I just were to call inline 1 like this, this inline 1 macro would be expanded. So this 10 plus 20 would get converted into this list, which is plus 10, 20, which is a normal Lisp expression that can be evaluated. So if I run this, we get 30 because it happens at two stages. First, the code is transformed and then that new code is executed. This might be a lot for the first time if you're looking at macros. We will come back to macros again and again, but hopefully this gives you an initial idea of what macros can do. If you go back to this example here, maybe this now makes sense to you. We want to use the backtick here because we want to actually use the value of message that comes at the macro call, which is here, right? So when you do f with city, we want to actually pass in with city as the message, which is then filled in to this string. But the macro itself would actually expand to this portion, which is the progen, print, and read line, which is just normal symbols that we have used and doesn't have to be changed. It can be actually just used as it is. Hopefully that's a good start, even if it's a lot of ground. And let's see where we go in future videos. See,